All right. Hi guys, my name is Lauren.
I'm Jasmine.
And I'm Mackenzie.
We're going to be covering chapters 10 and 11. So I'm going to talk about chapter 10 a little bit. The first major key point of this chapter was the chaos theory. So according to Wikipedia, the chaos theory is defined as, in layman's terms, as a part of mathematics in which a small change may cause a system to behave differently. So basically, in 1963, a man named Edward Lopez presented this theory in a lecture to his class, and this theory proposed the idea of the butterfly effect, which now has become the chaos theory. Now, there's several points wrong with this theory. There is no scientific proof that such cause and effect exists. Rather, this theory is more of a statement of faith. So there is really no way to prove that it is wrong or right. However, some background information as to how the chaos theory kind of formed. The data was collected and plotted by a group of mathematicians, but there was a specific mathematician called Henry Poincaré, I think that's his last name. And they attempted to find some patterns in the data. He did indeed find some patterns from lines to circles with lines through them. However, the idea never went anywhere and it was soon dropped off. But then Lopez came along and proposed the chaos theory that then takes the plots that were previously done with the data recorded, and then he builds on it. And then he started to see a correlation with the different types of patterns that emerge. And then this suggests that measurements we may find random in real life may indeed have some patterns. So that is just a little bit of background about the chaos theory.
So another big part with chapter 10 deals with Jerzy Neyman, and he actually taught himself a lot about the basics of math because the school system he was in didn't have adequate teachers at the time. He was also really well known for always being polite and kind to everyone he met, and he was always really open to questions from students. In 1928, he started working with Karl Pearson's son about the goodness of fit tests. And Neyman was also well known for his well-written mathematical research. His articles were always easy to read and understand. Others in the field had a lot of trouble explaining complicated ideas through writing without using a ton of graphs and other things that people just really couldn't understand if you weren't in that field. And one of Neyman's famous papers have been used in many different fields of studies that dealt with the problem in astronomy. And overall, Jerzy Neyman was a very intelligent man with research in various fields.
So this is chapter 11. Short chapter, by the way. So, moral story. So it was Egon Pearson and Jerzy Neyman, and they came together and they asked a question: what does it mean to have a non-significant result in a significant test, and can we conclude that a hypothesis is true if we fail to refute it? So whenever they came up with this question, let's see. So they created the hypothesis testing, and it's called the Neyman-Pearson. It's the Neyman-Pearson formulation of hypothesis testing, and this formula for statistics is still used to this day, and they claim that it's very simple to where first year students understand it, and it still applies today where the FDA, the EPA, and medical schools still use it. Let's see. So then Neyman made Wait, I actually got it. Okay, so, like, can we actually pause this for 1 second? And we'll just, like, add another video. Okay, we're back. I got it this time. So Naaman basically said a significant test made no sense if there was only one like set of data to compare your results with. So he said that the data had to have at least 2 distributions to compare your results with. So then on top of that, he also created the null hypothesis, the one that you're actually testing, and then any other hypothesis that came after that was just called the alternative. And so whenever he created this, he also set a fixed number, the p-value, and it is a test where if your p-value is less than 0.05, then you have to reject your null hypothesis. Well, he got this. He got the p-value from a guy named Fisher, and whenever Fisher read about what Naaman created, he didn't botch, but he was like very degrading on his like, what's the word for it? Like
Discovery.
Yeah, like he was very degrading on Naaman's discovery about it, and so for like the rest of his career, he just made it a point to just keep like attacking Naaman and everything that he finds. So, fun fact about Naaman, he was able to escape Poland before Hitler came and invaded it and did what he did there. He was able to come to the United States, and he taught at the University of California, and he started one of the most important academic statistics departments in the world. And another fun fact, he gave a seminar in France about something, and his arch rival Fisher came to just come and watch him and everything, and Naaman claimed that he was like very nervous because he knew he was gonna get reamed in like the post interviews. Fun fact: Fisher could even speak French, so he had no idea what he was saying the whole entire time. So that's our presentation. Hope you like it. Yeah.
Alright.